Hello everyone. In first lecture we have seen the property called as black body radiation, which confirms that light behaves as a particle. Today also we are going to study the property called as photoelectric effect, which also confirms that light behaves as a particle. So let us see what is photoelectric effect. Photoelectric effect is nothing but an instant emission of electron from the surface of metal when the light of particular frequency is incident on it. Means what? The metal surface is present, on that the light is incident of a particular frequency. From that incidence of light, the electrons get ejected or emission takes place, but the emission is instantaneous. This is the experiment which was performed by the Hertz scientist in 1887. In this experiment, the Hertz studied two parameters very closely, and that two parameters was frequency of light and intensity of light. Now we will see the experimental setup, and then later we will study how the effect of frequency and effect of intensity affects the ejection or emission of electrons. This is the experimental setup. First of all, you are going to see that there is a metal plate and it is connected to the battery. Then there is the presence of ammeter. Why ammeter is present? Because when electron will flow, then we will see the small amount of current which is being produced, or we can say that the electrons are flowing. Next, there is the presence of incident light. The low frequency of radiations will be incident on the metal surface. Then we will observe that there are no electrons, no single electron are going to eject from that surface. Later, we increase the frequency of that incident light. What we observe that at particular frequency of light, the electrons start to eject from the metal surface and they move towards the positive plate. What we observe that at particular frequency, the electrons start to eject from the surface of metal. And later, what we have done, again we increase the frequency of light. What we observed that the electrons were ejecting, but they were moving with the fast velocity. Later, what we have done, we are going to increase the frequency. Still, the electrons are being ejected, but the electrons' velocity get increased. What was the experiment? We have incident the light of the particular frequency. Then only we can see that the electrons are being ejected from the surface of metal. We have seen the experimental setup of photoelectric effect. Now let us study the effect of frequency on the photoelectric effect. What we have seen that the low frequency radiations were incident on the surface of metal, but then also we have not seen the electrons ejecting from the metal surface. Later on, what we have done, what we have seen that particular frequency, that electrons are started to eject. That means the frequency above which the electrons are started to eject from the surface of metal, that is called as threshold frequency. To this threshold frequency, there is a wavelength associated with it. So that wavelength is also called as threshold wavelength, and that threshold wavelength is given by lambda naught is equals to C upon nu naught. Nu naught is nothing but the threshold frequency, C is nothing but the speed of light, and lambda naught will be the wavelength associated with that light at which the electrons were ejected. Now next is what we have done next, that we have increased the frequency greater than the threshold frequency, and we have observed that the number of electrons remains same, but the kinetic energy of that electron increases. That means the electrons started to move fastly as compared to the lower frequency. When we increase the frequency, the electrons started to move fastly. These were the observations done with respect to the frequency. What observations we have done from this frequency? That the frequency which is lower than the threshold frequency, no current will see. Means what? No electrons will be ejected from the surface of metal. Next one, what is that? When the frequency of light will be equal to threshold frequency or greater than the threshold frequency, then only then the electrons will be ejected from the metal surface. On further increasing the frequency greater than the threshold frequency, what we will observe, electrons move faster. Let us study the effect of intensity. We have observed that the number of electrons from the metal surface goes on increasing when we increase the frequency, but the kinetic energy of that electrons remains same. That means if we want to observe the photoelectric effect, we will need only the threshold frequency. How? Because how intense the light is doesn't matter. That means if we want to observe the photoelectric effect, we doesn't need the intensity. Means what? It is independent on the intensity, because it is only depends on the frequency. How? If the frequency is less than the threshold frequency, then the photoelectric effect is not seen, or the photoelectrons are not seen. That means photocurrent is not seen. If we increase the frequency greater than the threshold frequency, then only we can observe that the electrons are ejecting from the metal surface. From this we can conclude that only the photoelectric effect is depend only on the frequency. It doesn't depend on the intensity. Now let us summarize everything. If the frequency is less than the threshold frequency, then no electrons will be emitted from the surface of metal. That means no photoelectric effect will be seen. But if the frequency is greater than the threshold frequency, then we can observe the photoelectric effect. That means at this frequency we can observe the photoelectric effect. That means if we increase the frequency of the light, then we can observe that the number of electrons which are ejecting, that will remain same, but the kinetic energy of that electrons will increase with increasing frequency. Later we have seen that the intensity does not affect the photoelectric effect. That means the photoelectric effect is independent on the intensity. Now how we can say that this proves the particle nature of light? When we say that at particular frequency the electrons are ejected from the metal surface, that means the threshold frequency. The threshold frequency concept comes, that means the light have the energy which is in the discrete. Now from this how we can conclude that the photoelectric effect is the proof that gives that light is how we can conclude that light behaves as a particle. The concept comes threshold frequency. Threshold frequency means what? The light is in the discrete form. That means, but we have seen that the light is in the continuous wave form. Next, that is, the wave theory tells that the intensity of light should be affected the electrons which are emitted. But in photoelectric effect, it is not seen that the intensity is affecting. That means it confirms that light behaves as a particle. So in further, you will see more lectures like this. Thank you.